All right, in this example, it's a differential equation. We're asked to find not just the value of the differential equation or the function itself that solves the puzzle. We're asked for the value of that mystery function at x equals 1. So here's our steps. Step 1 is going to be to find the solution to dy by dx is equal to 4x times g of y. Part 2 will be to use y of 0 is equal to 2 to find constant. Part 3 will be find y of 1. So we're going to solve the differential equation, use the initial condition to find the constant that will inevitably come out, and then evaluate our function at 1. So a 3-step problem. Let's go with the first step. I'm going to rearrange the differential equation. So we have dy over g of y is equal to 4x times dx, and then we'll integrate both sides. Now the question says that the integral on the left, antiderivative of g of y, is equal to 2y. So I'm going to sub that in. And on the right hand side, we can take the antiderivative of 4x and we get 2x squared plus c. And then we can divide both sides by 2. So y is equal to x squared plus 1/2 c. And you know, this thing where I'm keeping the 1/2 of the c, we can write it just as a different color c, make it like a blue c or a green c, or change the letter, call it an A or a B or a K. But I'll leave it, it's not important. So that's step 1. We found the general form of the solution, x squared plus a constant. Now let's use y of 0 is equal to 2 to find c. So 2 is equal to 0 squared plus 1/2 times c. So 2 is equal to 1/2 times c, and that means that c is equal to 4. Thus, we have y is equal to x squared plus 1/2 of 4, which is x squared plus 2. And the last part, find y of 1. Y of 1 is equal to 1 squared plus 2, which is 3. So altogether, not that bad. The bad part is reading the question and figuring out what it is that we're supposed to do. So I'll find y evaluated at 1, find the value of the mystery function at x equals 1. If the mystery function is defined in terms of this differential equation, the left-hand side of the integral is given to you as a gift, so you don't have to find it. And the right-hand side, the final piece, is the value of the mystery function at some other number, at 0, is equal to some output. And we use that to find the constant. Here's a second one of the same type. A little bit tougher to work with, not that bad still. We have another instruction to find y of 1. We have the differential equation that defines the mystery function. We have the integral of the resulting left-hand side that's given to us as a gift. And then we have some information that we'll use to find the resulting constant. So step 1, we're going to solve dy by dx is equal to 6x squared over f of y. This is it's separable, so I'm going to separate it. I'm going to multiply both sides by f of y and cross multiply by dx. So we have f of y dy is equal to 6x squared dx, and then we can integrate both sides. Now the question says that the antiderivative of f of y dy is 2 root y. So I'm just going to plug that in. So 2 times the root of y is equal to 6 times 1/3 x cubed plus our constant of integration. So 2 root y is equal to 2x cubed plus c. I'm going to find c right now. Step 2, find c using y equals 0 when x is equal to 2. So we have 2 times the square root of 0 is equal to 2 times 2 cubed plus c. So 0 is equal to 16 plus c, and that means c is equal to negative 16. So we can write down 2 root y is equal to 2x cubed minus 16. Let's divide both sides by 2. We can isolate for y. So root y is equal to x cubed minus 8. And then we can square both sides to get y all by itself, to get it out of the square root. Okay, and now we want to find y evaluated at 1. So y1 is equal to 1 cubed minus 8 all squared. So we have negative 7 all squared, which is 49. There's our answer. So a lot nicer than some of the other problems we're working on. The challenge is largely about decoding what the question is asking us to do. As a preview for what comes next, the field of differential equations is enormous. It's something you can almost classify as its own subject. There are graduate programs in differential equations. You get a PhD in differential equations. You can spend 50 years studying differential equations and just scratch the surface of what's there. It's an enormous field. The types of differential equations that have applications would be all of them. They all have applications. If you can write down differential equations, someone can find an application for it. We're not going to have any hope of solving all of them, especially not with pencil and paper. So I'm going to explain the types of differential equations that we're currently able to solve, the related types of differential equations that in general we can't solve, and then another type that we'll learn how to solve later. This type dy by dx is equal to a function of x times a function of y. This is the one type we've been working on for the most part. It's a separable differential equation. We can separate the x part and the y part, one side each variable. Some examples are given on the right-hand side. The more general form is if we have a mixture of x's and y, a mixture of functions of x and y. So where it's not possible to completely disentangle the x component from the y component. We couldn't, for example, divide both sides by g of y and then get an expression that's just in terms of y on the left, because we have another expression with h of x, k of y on the right-hand side there, and that would still remain. We could subtract it to the other side too, but now it's missing the differential, and it has an x term in it. And there's no, in general, way that we could rearrange this to be solved using a separable format. So the ones that are first order, non-separable, and have general form like this, we can't do much. At least not with the methods we've learned, and even with analytical methods that go much beyond what we've learned. We have to be very lucky. The problem had to be in a special format that permitted us to use some tricks to solve it. And some examples are written on the right hand side. Yeah, like look at that last one. Dy by dx is x cubed plus y cubed. Looks kind of innocent, right? But how are you going to integrate it? How are you going to rearrange it, or find the solution to the puzzle? Let's look at a special form, however, of that. let's say it's not f of x times g of y. Let's just say that g of y is y all by itself. So y multiplied by f of x, and let's say on the second piece on the right, instead of having k of y, we just have a 1 there. Now this is a special type of the above equation. It's a subcase of that, and it's called linear. The reason it's called linear is that it's linear in the variable y. It's not y squared, or square root of y, or 1 over y, or e to the y, or ln of y. It's just y. Some examples are given on the right-hand side. This first order linear differential equation can be solved in a very beautiful way. Now we'll see how to do that. There's also all other types of differential equations. There's differential equations where the dy by dx is, let's say, squared. The derivative squared is equal to something. So nonlinear differential equations. But excluding those ones, if we think about what else is there other than first order separable, first order non-separable, first order non-separable but linear, there's also second order. So equations that involve the second derivative of the mystery function, and sometimes also the first derivative of the mystery function. And then there's third order and fourth order. There's all types, all different types. And we're not going to touch the second order differential equations except for that one example I just said. We'll show it's the solution. We're not going to go after those. Some examples are shown on the right. They are important. Many mathematical models require second order components inside the differential equation, but we have to draw the line somewhere, right? Can't cover everything in a course, so we're not going to cover those. If you think about, what are we doing next? We have the skill of first order separable. We have that done. I'm telling you the second category there is a locked skill. We are not going to upgrade that. The last one there, we're not going to upgrade that, but we are going to upgrade that linear first order, and that's in the next video.